Hello everyone, this is Santosh Kumar. Welcome to LIPS Research. We craft comfortable, international research education. Today we are going to see about jet engines and types of jet engines. Turn your eyes to the sky and it's likely you'll see more than a few vapor trails, the wispy white lines that jet planes scribble on the great blue canvas stretched above our heads. At the dawn of the 20th century, the very idea of powered flight seemed, to many, like a ludicrous dream. How things have changed. At any given moment, there are something like 5,000 flights zipping through the sky over the United States alone. We're so used to the idea of flight that we barely even notice all the planes screaming above us, hauling hundreds of people at a time to their homes and holidays. Most modern planes are powered by jet engines, more correctly, as we'll see in a moment, gas turbines. What exactly are these magic machines and what makes them different from the engines used in cars or trucks? Let's take a closer look at how they work. What is a jet engine? A jet engine which works under the principle of Brayton cycle. A jet engine is a machine that converts energy-rich, liquid fuel into a powerful pushing force called thrust. The thrust from one or more engines pushes a plane forward, forcing air past its scientifically shaped wings to create an upward force called lift that powers it into the sky. That, in short, is how planes work. But how do jet engines work? A jet engine uses the same scientific principle as a car engine. It burns fuel with air, in a chemical reaction called combustion, to release energy that powers a plane, vehicle, or other machine. But instead of using cylinders that go through 4 steps in turn, it uses a long metal tube that carries out the same 4 steps in a straight line sequence, a kind of thrust-making production line. In the simplest type of jet engine, called a turbojet, air is drawn in at the front through an inlet, or intake, compressed by a fan, mixed with fuel and combusted, and then fired out as a hot, fast-moving exhaust at the back. 3 things make a jet engine more powerful than a car's piston engine. A basic principle of physics called the law of conservation of energy tells us that if a jet engine needs to make more power each second, it has to burn more fuel each second. A jet engine is meticulously designed to hoover up huge amounts of air and burn it with vast amounts of fuel, roughly in the ratio 50 parts air to 1 part fuel, so the main reason why it makes more power is because it can burn more fuel. Because intake, compression, combustion, and exhaust all happen simultaneously, a jet engine produces maximum power all the time, unlike a single cylinder in a piston engine. Unlike a piston engine, which uses a single stroke of the piston to extract energy, a typical jet engine passes its exhaust through multiple turbine stages to extract as much energy as possible. That makes it much more efficient. It gets more power from the same mass of fuel. Working principle of jet engine. For a jet going slower than the speed of sound, the engine is moving through the air at about 1,000 km per hour, 600 miles per hour. We can think of the engine as being stationary and the cold air moving toward it at this speed. A fan at the front sucks the cold air into the engine and forces it through the inlet. This slows the air down by about 60% and its speed is now about 400 km per hour, 240 miles per hour. A second fan called a compressor squeezes the air, increases its pressure, by about 8 times, and this dramatically increases its temperature. Kerosene, liquid fuel, is squirted into the engine from a fuel tank in the plane's wing. In the combustion chamber, just behind the compressor, the kerosene mixes with the compressed air and burns fiercely, giving off hot exhaust gases and producing a huge increase in temperature. The burning mixture reaches a temperature of around 900 degrees Celsius (1650 degrees Fahrenheit). The exhaust gases rush past a set of turbine blades, spinning them like a windmill. Since the turbine gains energy, the gases must lose the same amount of energy, and they do so by cooling down slightly and losing pressure. The turbine blades are connected to a long axle, represented by the middle gray line, that runs the length of the engine. The compressor and the fan are also connected to this axle. So, as the turbine blades spin, they also turn the compressor and the fan. The hot exhaust gases exit the engine through a tapering exhaust nozzle. Just as water squeezed through a narrow pipe accelerates dramatically into a fast jet, think of what happens in a water pistol. The tapering design of the exhaust nozzle helps to accelerate the gases to a speed of over 2,100 km per hour, 1,300 miles per hour. So the hot air leaving the engine at the back is traveling over twice the speed of the cold air entering it at the front, and that's what powers the plane. Military jets often have an afterburner that squirts fuel into the exhaust jet to produce extra thrust. The backward-moving exhaust gases power the jet forward. Because the plane is much bigger and heavier than the exhaust gases it produces, the exhaust gases have to zoom backward much faster than the plane's own speed. In brief, you can see that each main part of the engine does a different thing to the air or fuel mixture passing through. Compressor dramatically increases the pressure of the air, and, to a lesser extent, its temperature. Combustion chamber dramatically increases the temperature of the air-fuel mixture by releasing heat energy from the fuel. Exhaust nozzle dramatically increases the velocity of the exhaust gases, so powering the plane. Types of jet engine. There are three types of jet engines: turbojet, turboprop, and turbofan. Turbojet engines. The turbojet engine is a reaction engine. In a reaction engine, expanding gases push hard against the front of the engine. The turbojet sucks in air and compresses or squeezes it. The gases flow through the turbine and make it spin. These gases bounce back and shoot out of the rear of the exhaust, pushing the plane forward. Turboprop engines. A turboprop engine is a jet engine attached to a propeller. The turbine at the back is turned by the hot gases, and this turns a shaft that drives the propeller. Some small airliners and transport aircraft are powered by turboprops. Turbofan engines. A turbofan engine has a large fan at the front, which sucks in air. Most of the air flows around the outside of the engine, making it quieter and giving more thrust at low speeds. Most of today's airliners are powered by turbofans. In a turbojet, all the air entering the intake passes through the gas generator, which is composed of the compressor, combustion chamber, and turbine. Before we go to the conclusion, we will see an interesting fact. Aircraft engines are very costly. Because airlines always buy their aircraft with the engines attached, it's difficult to say just how expensive they are. And the price varies per engine type, of course. Roughly speaking, prices range from $12 to $35 million. Thank you for watching with Lips Research.